Where we've been, 8-1. A1 was your polygon angle fun. Sure. So with polygon angle fun stuff, you have the sum of the interior. And the sum of the interior angles of any polygon was always the same generic formula. We took the number of sides, subtracted 2, and multiplied it by 180. The reason that we did that is because we found that every time we had a polygon, you could create, you could create what are called non-overlapping triangles, and then knowing that the sum of the triangles, and you just added them up. Okay. We also knew that you could also find the sum of the exterior. What was the sum of the exterior angles always? 360. Okay. Now what we did was there was a couple of ways of solving depending upon what type of polygon or the type that you had. Sometimes we had things that were called regular. What were regular polygons?
Like your
That's what I was going for. Thank you. Say they're octagons, pentagons, yes. But what makes it more specific is the fact that you have what are called regular. Regulars all have the same side or same side lengths, same angle measurements. So these are the more specific. So they have same angles and same sides. So if you want to think of it, these are all just congruent angles and congruent sides. It's kind of an easier way to say it. Now, usually what we did with these types of problems is that we were given something, let's say, an octagon. So we would ask, hey, knucklehead, what's the measure of each interior and exterior angle in a regular octagon? So if I wanted to know the measure of interior and exterior in a regular octagon, not regular October, what was the easiest thing to do? Was it easier to work with the inside or the outside? Outside. It was always, always, always easier to work with the outside angles. Now, do you remember when I showed you guys this little trick? Now, what's nice about doing that is that no matter what, somewhere along the lines in any polygon, you're going to have three sides that connect. I don't draw it like this when I have a triangle because that's just silly, or a quadrilateral, but every other one of them, somewhere, somehow, there's going to be three sides that intersect, and it's a very easy way to work with inside and outside angles. So knowing that you have an octagon, how many sides are in an octagon? 8. All right. So what we would do is, it's always easier to find the outside angle first, the exterior angle. All you have to do then is take 360 and divide it by what? 8. When you do that, you get 45. Okay? 45 is your outside angle, which means your inside angle is its supplement, which is 135. Okay? That was the easy way of doing that, which also led you guys to be able to figure out a nice shortcut for figuring number of sides. Okay? Now, the shortcut we found for finding number of sides was this. If we took 360 and divided it by excuse me, the exterior angle. If we took 360 and divided it by the measure of that exterior angle, that always gave us the number of sides. And the reason that happened was because if this equaled 45 degrees, remember, fraction equal fraction, we could do that exchange-o, and it's still the same ratio, okay? That's what's nice about ratios, the good old-fashioned exchange-o. So that's why you're able to do that little trick, okay? Vaguely ring a bell?
No.
Oh. Let's see this. So many files, so little. I'll just do this.
Nice.
The measure of the interior angle is, what was it? I forgot, was it $1.65? Yeah. This is regular polygons. Okay, this would be regular polygon. So the measure of each interior angle in a regular polygon measures that $165. How many sides does it have?
Draw your little picture.
It could be 24.
Okay.
You do that shit.
Guys are just ruining it for me. Are you guys, any of you guys reading like Mice and Men this year, or is that the junior one?
What?
That's junior. You do?
Read what?
Okay. Remind me when you're done reading it, I have something to show you.
What did you say?
This guy said that I don't read any song. It's so awful. It is great. So remember, it's always easier with anything with regular polygons. Always work with the outside. So if you have 165 here, it means you have 15 there. Take 360 divided by 15, and you are left with 24. So you have a 24gon because it is not a double dodecagon. The double decker decagon. Get it? Double dodecagon.
Maybe a dodo. Dodo to math.
Boo. Boo. Alright. And there was any other crazy stuff here.
Just off the top. Here, right here is what? 165, 155.
That's a good one.
How many is here?
The measures of the exterior angles of a convex hexagon are 45, 60, x, 3x, 7x, and 90. What's the measure of the largest exterior angle?
Wait, what?
Actually, you know what? I'm going to change that. What's the measure of the largest interior?
Why you make it harder?
Because I'm a jerk. And that's what I do. So, work through it. Think about what the question's asking you. The measures of the exterior angles of a hexagon are 45, 60, x, 3x, 7x, and 90. What is going to be the measure of the largest interior angle?
The one with
I
the
don't know.
smallest section.
I have another problem yet. I just made it up.
One of the largest sections. What about this? 36 equals, what's 45 plus 60? 45 plus 60? Yeah. 105. You gotta add all the angles up, don't you?
Oh, there's a 90 inch. I
So
see.
that's gonna be 11 x
Yeah, and 90.
plus 90.
Oh, I didn't wear greenish.
105 plus 90, 195.
So you take
That's mental.
Well, no, it was me and then it was Bob Tops for the shirt.
Equals 36.
And we were like in
Subtract
descending
195.
shades of green.
Six minus two.
Basically the exact same.
You don't know what 6 minus 2 is?
So,
Oh wait, no, you subtract 360.
how many degrees are in on the outside? All right.
160.
So we have. So let's see. We have 11x plus 105 and 90 is 195.
I see 195.
So we get for x
15.
15.
Yeah. You gotta plug it back into X.
So if x is equal to 15, right there, doesn't that give you the smallest exterior angle?
Yeah.
Which means what's the largest? There you go.
But it's not.
So the reason why this has to be the smallest exterior angle, because right here, when you substitute back in,
It's 15.
it's 15.
So
So
that's
if 15
gonna be
degrees
minus
is your
2.
small exterior, that means the small exterior has the largest interior. It's a nice little trick question. I like that. Okay. It makes you have to do two things. And you have to think. So 3. I'm asking a lot here. Sorry.
It's okay.
Okay. Now after that
Just don't
then,
do it again.
in 8.2 and 8.3,
Do it again.
it was kind of the exact same thing. Yes. Properties of parallelograms. They're exciting. No, they're not. So, parallelograms. Sounds like that should be like a cereal. Gotta get my parallelograms.
No.
Patent pending, patent pending.
They're gonna be cinnamon. They're gonna be cinnamon. That sounds good.
What if I just made a bunch of little parallel signs? And then I can mix in like marshmallows of angle symbols and congruent symbols.
You do that
Your
at
cereal teaches you.
like the one that looks like this.
The two parallel lines, cut, right, transversal stuff. Oh yeah. Patent pending.
Math is gonna kill me.
I doubt it.
Yeah.
If you choke on parallelograms, you might.
Oh, you're terrible.
I am. Opposite sides are what?
Okay,
They're congruent. Opposite sides are. Opposite angles are. Congruent. Consecutive angles are. Supplementary. And then last but not least, you've been gone for 3 days, man. Write something down.
Oh, I have the.
And then last but not least, what we know about diagonals?
They're a sector.
They're secondary. Right?
Oh, stop.
So, in all honesty, the only mistakes that I've been seeing with this whole idea of big picture problems with the diagonals and all that, sometimes people think that sides add up equal 180. They don't. They could, but they don't. Only angles when you set them equal to, you're either going to set them equal to each other, or you're going to put them equal to 180 depending upon where they are. They're across from one another, they're equal. If they're next to each other, no matter what, they're always going to be 180. Okay? After that, everything else is just pretty straightforward. So what we have then tonight is I just ran off a sheet of a whole bunch of just review problems, really. Just nothing.
Yes,
No.
test this tomorrow.
We got quiz.
Question mark. We don't know. Question mark. I know what.
You do.
I'm just gonna sit back here and cover my face.
Hey, Logan, you ready?
No.
You ready, kid?
You don't know this? I know you do. You know this, right?
Yo, I didn't hit a semi this time. I haven't hit.
This man, we were going around the curve at Walmart, by Walmart, he almost hit a semi. I was in the back seat.
Hey,
This
do
man
this on a
almost hit a
separate sheet of
semi.
paper so you have space. This is basically said that way you didn't have.
He got too many clothes.
So you guys see what's going on tomorrow?
Oh, it was a bad throw, right?
He got two clothes. I thought, oh no, we definitely hit this semi. Hey, you got lucky.
Why are you yelling at someone?
Because you're yelling.
Stop yelling at people.
Anthony,
What?
be quiet.
Listen, sorry.
Mr.
In a
Murphy,
nicer tone.
you know,
Hey guys, I'm giving you guys some time right now. I expect you to start working through it. This will not take long. Do we have? Yeah, just out of the back of the book instead of having you guys, here you go, post it out so it's just a little bit easier to run it off real quick. We will quiz this stuff through tomorrow. Guys, we will quiz through this stuff tomorrow. On Monday then, we will start with the rectangles and squares and rhombuses, oh my. We do rectangles and rhombuses the same day, if I'm not mistaken. And then we do squares after that. I don't know. There's really not a whole lot of stuff going on in chapter 8, to be honest with you. It's pretty straightforward. Okay?
That's all? You
Oh.
don't use distance
Hey.
at all?
Slope is easier.
Oh, you can use either or.
Yeah.
Either or.
Yeah, you use either or. Slopes are always easier because it's less work. I saw a really cool way of doing slopes.
Playing the dog whistle.
I had a kid show me this.
Ian.
When you do, if you do slopes, if you want to look at
Who's playing the dog whistle? I will personally.
guys,
Let's get started.
Austin,
So it's playing
Oh.
a dog whistle.
just
how can you hear it?
what she did was, I guess they show them it this way.
So you're referring to them.
Enough. Both, everybody, stop. Part of this, don't you guys get? Subtract. Subtract. I never saw it like that. Oh, sorry. this
Because
was
you're
negative.
lining
Yeah.
up,
Oh,
because
sorry.
you're lining up your,
Yeah.
you're lining up your negative, your x's and your y's that way.
Yeah.
And then you've got it in the right order for your slope.
Right.
That's interesting.
I never saw that. Huh. It's weird.
Yeah.
But it doesn't, it's kind of hard for you to be able to do, you know, if your slope equal, you know,
Yeah, do you see that?
it's hard to do what's missing.
Would it be hard though? Like if we were missing that whole, we're just missing that one or we're missing that order?
No, just missing the one part. 'Cause if this is your missing y value, I mean, I guess you have 5 minus what equals -2.
Yeah.
Well,
If I'm at -2 and I want to get to 5, I have to move 7.
right. Yeah, I get it. Yeah,
That's interesting.
I never saw it like that. It's different. I haven't
Have
either.
you seen it? You haven't seen it? No.
You guys ever? All right, I'll show you. Hey, look at this real quick. I had a kid show me this yesterday.
But Mr. Murphy, always in the middle of thinking.
Well, think
Stop
it over.
thinking.
I had a kid show me this the other day.
Okay.
If I want to look at number 23 real fast, and I need to find the slope of AB. Now, normally what we would do is we would write out our slope equation, change in y over the change in x. And I'd have 3 minus 2 over -6 minus -8. And I'd get 1/2. You okay with that? Well, a way a kid showed me was this. If you take your ordered pairs, like that, and then you just subtract down. What's 2 minus 3? It's -1. -8 minus -6 is -2. What's -1 over -2? 1/2. It works. It's just another way of writing it out. It's just another way of writing it out. I never saw that before. I thought it was kind of neat. It's just another way of doing it. It's just another way of doing it. You're just subtracting here and here. You're doing vertical math as opposed to horizontal math. That's all. So your X's go down to here, and your Y's go right there. It makes, by making that little L bracket, it just makes it into that little top part of the fraction then.
You should have gave him student a cookie.
What's that?
You should have gave him a cookie.
I didn't have any.
Oh, you should buy cookies.
Yeah, no.
Oh, I'll buy them for you.
No thanks.
Okay.
I appreciate those. Because we bought some Girl Scout cookies, because, you know, that's what you do. You only get 14 tag-alongs in a box for $4. Highway robbery.
Yes.
Highway
Drive.
robbery. What's that?
Actually, but those image that you guys